learn together, pass together, grow together. So, our today's topic is switch. What is switch? Switch is the thing that lets devices on a local network talk to each other intelligently. And that word intelligently matters because if you compare it to that what comes before it, the switch starts looking absolutely amazing. Back at the example.com, this is the device that connects the POS terminals, office PCs, printers, and maybe the back office server all on the same local network. Without it, our devices are just lonely island with Ethernet ports. With its switch, they can communicate fast, cleanly, and with purpose. That's the magic. Now, physically, it doesn't look all that dramatic. It's a box with ports, plug in one device, plug in another device, and off they go. But under the hood, some awesome stuff is happening because those Ethernet cables are carrying electrical signals over metal wires, and the switch is receiving those signals and deciding where they need to go. You might be thinking or have a question like why the switch is better than hub. To really appreciate a switch, I had to show the ugly thing that came before it, the hub. And yeah, I am being a little dramatic, but only a little, not too much. Okay? A hub is a dump. It has no real decision making ability, no memory, or nowhere devices are, no fineness. It just repeats incoming traffic out of every port like a kid yelling your private conversation across the whole coffee shop or somewhere you are in a big gathering. Okay? That's the core difference. When one device sends data through a hub, everybody gets it. And this is absolutely absurd. The intended recipient gets it, sure. But so does everyone else connected. Most devices will ignore traffic not meant for them, but that's still inefficient, noisy, and not exactly secure. Because you also think that when we send someone a message, which can be a private message, so if we send through a hub, it goes to everywhere who will connect it to the hub, and it's not okay. It's not okay that I want to talk to him personally, I want to talk to him or her personally, but everyone gets the answer what I am asking her. So, hub is such a dumb. Like, if we ran a service.com shop that way, every registry, every laptop, every random connected devices would be hearing things they don't need to hear. So, but a switch fixes that. When Johnny sends traffic to Mark, the switch sends it to the Mark only. Not Lisa, not Danny, not anyone who connected in the whole network. Just Mark. That means less noise, less wasted bandwidth, and a far better network experience overall. That's why switch is smart because it decided where to go and whom to go. Not everywhere to go that I have a message, I'll send you all and you will find that who want to read it or who is the owner of that message or receiver of the message. A hub blasts traffic everywhere, a switch sends traffic where it actually belongs. That one difference changes performance, security, and sanity. So, now how a switch conducts traffic? Here is the big question, right? How does the switch know where the mark is? It's not psychic, it learns. That's what makes it smart. As devices communicate, the switch builds a little mental map of which device lives in which port. This map is called CAM table. Content addressable memory. You don't have to obsess over the name right now. What matter is what it does. A switch watches incoming traffic, looks at the source MAC address, which is the hardware address burned into the device, and says, yeah, that device is on this port, got it. And then it stores that information. So later, when traffic comes in destinate for a certain device, the switch checks the destination MAC addresses and forward the frame to the correct port. Boom, efficient communication. That's why switches are so much better than hubs. They learn where devices are, remember it, and use that information to make forwarding decision. Sidebar for the moment. This is why one of the first useful Cisco commands you will ever learn in show MAC address table. This is a Cisco CLI command which tells show MAC address table. Okay, you are literally peeking inside the switch's brain to see what it learns. Sidebar done. Layer 2. MAC addresses and frames, because switch is working on layer 2 where it works or it's communicated through the MAC addresses of the devices, and the data is called frame in layer 2, and we learned it yesterday. Yes. A switch operates at layer 2 of the OSI model, which means it cares about MAC addresses, not IP addresses. That's a huge distinction. When you type a ping to an IP address, you are thinking in terms of layer 3, the network layer. That's where IP addresses live. But the switch itself doesn't really care about that part. It focuses on layer 2 envelope, the part that contains the source and destination MAC addresses. And when we are talking about layer 2 traffic, the proper term for the message is frame, not a packet. Well, okay. Technically, at layer 2, it's a frame, and at layer 3, it's a packet. This, in the real world, engineers blur those terms all the time, but I want you to see the distinctions now because it helps the whole picture click. Switch equals to layer 2 equals to frame equals to MAC addresses. I also brought wireless into the conversation because people also or often use Wi-Fi is doing the exact same thing as a switch. Short of, but not exactly, a wireless access point connects wireless devices into the network, usually by plugging into a switch, but the wireless side behaves more like a shared medium. When wireless traffic is sent out, it's kind of like everyone in the room can hear it. That's not the same clean, direct behavior we get from weird switch ports. So while wireless is amazing, convenient, and absolutely necessary at example server for guest devices and mobile and phones, it's still not my first job or first choice when I need maximum performance and reliability. Because the wireless access point is like just like hub, not that much, but it's like hub because the devices are connected on the wireless. So when the wireless access point receive any message to send it to the network, it broadcasts to every device which is connected through Wi-Fi. Okay, so it's something like hub. Wireless has improved a ton, especially with newer standard like Wi-Fi 6, but a wired connection is still king when you want stability, predictable speed, right? I'll give you a 4 takeaways. A switch connect devices on the local network and send traffic intelligently. It's better than hub because it doesn't flood traffic out of every port. It learns devices location using source MAC addresses and stores them in a CAM table. It forwards traffic using the destination MAC address, which makes it a layer 2 device dealing in frames. Okay?